This is Physics 2 Lab 6 Magnetic Molasses. So the purpose of this lab is to observe Faraday's law by dropping a magnet down a tube of conducting wire to observe how Faraday's law will slow down the falling speed of the magnet. The system of this lab is the magnet we're dropping, the surroundings are the tube and the earth. Um, and then the initial conditions are that the magnet is being held stationary right above the tube with gravitational potential energy. So some of the physics principles that we use, obviously, is Faraday's law. So that's the notion that a changing magnetic field will produce an electric field, which will then produce in a magnetic field um, in the opposite direction, which should slow down the speed of the falling magnet. Force of gravity, of course, the magnetic field of a ring slash solenoid. So this is what's going to be produced after the electric field is produced by Faraday's law. Ohm's law. So this is kind of just relating the EMF produced by Faraday's law to a current. Um, and then the magnetic force, of course. So here's the experiment. As you can see, this is the initial conditions right here. I'm gonna go back, my fault. And then here, just kind of some of the figures I got in the actual experiment. So the weight of the magnet was 24.35 grams. The height of the cylinder was 30.82 centimeters, as you can see. The thickness of the aluminum foil, so that would be like right here from this edge to when it hits the edge of the tube itself. Is 0.55 centimeters. And then the 5 times we got were 0.8 seconds, 0.73 seconds, 0.73 seconds, 0.83 seconds, and 0.74 seconds. We measured all these by taking a video and splicing the clip until as soon as it basically entered the tube and to when it exited the tube. Because of this, we had an average time of 0.766 seconds of falling. And then as you can see here is my glow script model. And so I'm not going to go all the way into detail, but here are just some sort of the functions and just like key components of my model that made it work. So yeah, and then we'll look at the results right now. So here's the results. Here's the graph I got. Um, Basically, I got an average time of 1.319 seconds, which is quite a bit off of what I had done in real life, which means there's most likely both some experimental and computational errors. Um, and so we'll kind of look at that. So here are some possible sources of error in my lab. Being that the timing was calculated from videos taken on my phone, the lack of frame rate on my camera on my phone could have accounted for a difference between recorded time and actual time. Maybe if my camera had shot in a higher FPS, I could get a more exact time. Um, And then another experimental error could have been that we did not use enough aluminum foil to make the effect of Faraday's law strong enough. Um, and so there's two possible sources of error right there. And then just like the two questions for the lab are, what if the resistivity of the conductor were reduced to as close as possible to zero? How would the dynamics of the falling magnet change? So if you look back at Ohm's law, um, basically it would say that V equals I over R. Um, and so if the resistivity was zero, then that would basically mean that I would increase to infinity. And it would basically mean that V would also increase to infinity, meaning that the braking force of Faraday's law would become so strong that the magnet would kind of just become stationary in within the tube and it would just stop falling altogether. And then the second question is, what if holes or slots were cut into the tube? How would this affect the ring currents in your model? So current would not be able to flow smoothly, and the braking force would be negligible compared to the gravitational force. So there would be no slowing of the magnet at all. Um, so basically, this would kind of ruin the experiment, um, and you would not really be able to see the effect of Faraday's law. So that's all I got. Thank you.